Good morning, folks. We were wrapping up some work on propositional logic, and as I said, we're not going to go too far into this, largely because this is a survey of logic course. We're touching on a whole lot of ground in logic and critical thinking, not going into too much technical detail on absolutely everything. I wanted to end with an example from propositional logic, which we had been working on last time. This is a fairly simple argument that I just cooked up. You could imagine someone making an argument of this nature. And by the way, keep in mind, the validity is not determined by the truth or falsity of the premises. So when you're asked whether or not the argument is valid or not, don't get mired in the truth or the falsity of the premises. If you're asked about validity, the question is it structured in such a way that if the premises are true, that the conclusion will follow by logical necessity? Validity is a question of structure. And I apologize if I've repeated that 10 times or more over the course of the last 2 weeks. But you would be surprised the number of people who continue to get that issue wrong. And I don't mean in this class. I'm talking about over the last 20 years that I've been talking about things of this nature. So I think it's fair to say it again. Now here's the argument. If the U.S. backs out of the climate treaty, then the U.S.'s global leadership will be jeopardized. If the U.S.'s global leadership is jeopardized, then the U.S. economy will certainly suffer. We cannot have the U.S. economy suffer, so the U.S. should not back out of the climate treaty. Now, the question isn't whether or not the premises are true if we are asking if the argument is valid or not. The question is, does the conclusion follow, structurally speaking, if the premises are true? Now, here is how we would put this one into logical structure. And by the way, folks, it is irrelevant what letters you use to fill in, to symbolize the context. However, make sure that whatever letters you use for a particular bit of content, that you keep it in mind, so when you see that content again, you use the same letter. In other words, you have to be consistent. Otherwise, you'll foul up the process. Now, that first sentence is written this way. If the U.S. backs out of the climate treaty, B for backs out of the climate treaty, could have used C. I mean, it doesn't matter. You could have used X or whatever. I just used a letter that was conveniently part of the phrase. If the U.S. backs out of the climate treaty, then the U.S. global leadership will be in jeopardy. Conditional statement. You've seen these before. Second premise, I said, if the U.S.'s global leadership is in jeopardy, could have used L, just to throw that in there, then the U.S. economy is certain to suffer. I just called S for certain to suffer. But we can't have the U.S. economy suffer. That simply means not S. Now, I have the conclusion written this way. It says, so the U.S. should not back out of the climate treaty. That's written as not B. Now, I wrote it over here because we are actually asking the question, can we validly deduce this, provided that these premises are the case? And I have this over here, but I'm going to write it down again. I'm going to talk you through it. This is kind of the process by which a formal propositional logic proof would be done. The good news is this one is what? It's extremely simple, so we can get through it briefly. Now, what we're trying to do is to solve for not B. And by the way, the kind of language I'm using here might remind you eerily of what? Yeah, it might remind you eerily of math. You know, solving. Can we solve for this? This may structurally also remind you of a geometry proof for some of you who might remember geometry. Recall that you were asked to determine whether or not we could derive something if a whole bunch of things were given, that is, that we were supposed to take as being the case. Well, that's kind of what we're doing here, except we're doing it with linguistic content, symbolized in terms of letters to stand in for the content and connectors to stand for the relationships. Now, the first step in this proof, I can derive, because I have if B then J and if J then S, I can derive B therefore S. And I have it there on the notes, but I just would have over here in parentheses the rule of inference that allows me to draw that. Hypothetical syllogism, premises 1 and 2. Now, simple enough, I look at this. I have if B then S, but not S, I can derive not B. Modus tollens, given premise 3 and derive premise 4. It has been demonstrated. Using the rules of inference is, and by the way, we didn't learn all the rules of inference. There's more of them. But from the ones that we did learn in the textbook, this conclusion follows. Now keep in mind, simply because this conclusion follows validly doesn't mean that the argument is sound. In other words, we would still have to be sure that the premises are true. Now, just for fun, you may not find this funny, but I'm saying just for fun, there was actually another way that we could also derive B. There's sometimes more than one way using the rules of logical inference that you can get to the right conclusion. Now you might notice here that I have if J then S, but not S. That should remind you of modus tollens. So I could have done it this way. Derived premise not J, modus tollens, premise 2 and 3. B therefore J, but not J. Not B, modus tollens, premise 1 and 4. That's another way I could have done it. Sometimes there's more than one way that you can get to the right answer. I just wanted to make sure you understood how something like this works. I will not give you anything propositional logic-wise that is any more complicated than this one you've seen right here. Note if you were to take a 200-level logic course somewhere else where there's more time being spent on propositional logic, you might spend 3 or more weeks on propositional logic, a good deal more would be expected. But the fact is, all of the more challenging stuff is basically based on an understanding of the basics. In other words, if you understand the basics, you can certainly do things that are not quite as basic. Just wanted to make sure that I showed you an example of how some of these things operate or work. Now, something else I just wanted to show you that's not in the book. It's another one of these rules. Suppose my first premise is P. Doesn't matter what P is. Suppose my second premise is Q. Guess what further inference I can draw here? And this is a connector that the author of the text did not give to you. It's called conjunction, which stands in for our word and. And the logical symbol that's used in propositional logic is called the dot. You saw that symbol that looks like a V that stands in for or. This is the symbol that logicians use to stand in for and. If P is true and Q is true, I can say P and Q. Now you might ask the question, well, so what? Of course, if P is true and Q is true, then the statement P and Q is true. Why would I want to do that? Well, it turns out that when you're doing logical analyses, you have to make sure that all of your steps are shown. In a longer proof, there may be a reason why you might have to combine something like this in order to draw other inferences. Or let me show you another one. If you can say P and Q, guess what you can say individually? Yeah, you can say P individually. You can also say Q. This is a rule called simplification. It's not in the book. This is a rule called conjunction. Yeah, one more, and we'll get right to categorical logic. Suppose I have the premise P. I'm allowed to do this. If P is true, you can also say P or Q, regardless of what Q is. And this is because if you know that P is true, anything you tack onto it with an or will still remain a true statement. Because an or statement only needs what to be true? One side. So you can technically add anything on with an or, and it will still remain true. This is a valid propositional logic inference called we're adding something on. It's called addition. That's the nice thing about some of these names. They're named after the very thing that you do. Conjunction, conjoining two things together. Just wanted to show you some of those other things that can be derived that weren't mentioned in the textbook. Now, folks, we're going to continue from propositional logic to go over some of the basics of categorical logic. I will expect a little more from you folks when it comes to categorical logic than the textbook provides. Thus, there will be more lecture on it, and there will be more in my notes about categorical logic than is in the textbook. The textbook gives you all of the terminology that you need. But there is some explanation that I think needs to be made for improved understanding. Categorical syllogisms. Now here's some groundwork that's not mentioned in the textbook. I've already told you that syllogism is a term used for any argument that has three statements. Two premises, one conclusion. You've seen the disjunctive syllogism and you've seen the hypothetical syllogism from propositional logic. Categorical logic has a much longer history. It goes all the way back to the ancient Greeks. It was exhaustively codified by the Greek philosopher Aristotle. That's just some historical information there. Now, the reason why we call them categorical syllogisms is because the fundamental unit that we will be relating to one another in categorical logic are categories of things. If you don't like the word, categories, you can find some other synonymous word, but a category you might think of as a class of things, or if you prefer, a group of things. And this is in the textbook. It's also further in my notes. But I will give you one of the simplest categorical statements that you may have already encountered. It is what we call an A statement. This is an example of an A statement. All wombats are marsupials. Now, this word all right here, it indicates more than one thing. It indicates the quality, and by the way, by quality, we mean, is it an affirmation or is it a negation? All says is an affirmation. It says that certain things are something else. Now, when I say it also talks about quantity, we are talking about every single member of a particular group. Not some, all. So this all statement is sometimes called a universal affirmative or a universal affirmation. Don't worry, I'm going somewhere with this. With this example of a categorical statement, we're relating this category to this category. Now, just like in your grammar class, circa, I don't know what grade it might be. I guess it depends on your where you grew up or whatever. This side of the statement, the side that comes before the linking verb, is the subject. The side that comes after the linking verb is the predicate. So every categorical statement has got to have a subject and a predicate. And they will be two categories of things that are being related to one another. And every categorical statement will have a linking verb. The technical term for the linking verb is the copula, another Latin phrase. It will link the subject and the predicate together, and the quantifier and the qualifier will tell us what the relationship is. All wombats are marsupials is a true categorical statement. Why is it true? Well, because wombats are a subset of the class of things marsupial. This is indeed an example of a true A statement. Now, folks, the beauty of categorical logic, and this is also something about it that might not be beautiful, there are only 4 kinds of relationships that we can convey in categorical logic. This is in the textbook, but I think it's done a little more haphazardly than I'm going to do it here. The 4 kinds of categorical statements that are legal are what we call A statements, E statements, I statements, and O statements. And I'm sorry, but you're going to need to know what an A, E, I, and O statements are. Easy enough to memorize. Now, an A statement you just saw. We call it a universal affirmative because it's talking about all members of a particular class, and it's making the affirmation that one group is a member of another group. All wombats are marsupials is an example of a universal affirmation. E statements. Universal negation or universal negative. Since we're sticking with wombats for the moment, no wombats are grasshoppers. That is a true universal negation. What it's saying is that there's no members of this class that are members of this class. I statements are known as particular affirmatives or affirmations. It doesn't matter what statement. Some Republicans are pro-choice on the abortion issue. So what this is saying is there's some people who are part of this group who are a part of this group. Now, finally, I statements are a particular negation or a particular negative. And to stick with the theme, some Democrats are not pro-choice. Now, it's irrelevant, but I did my best to make all of these statements true. Three kinds of statements, A, E, I, or O. Now, let's talk about what the argument looks like. These are what the kinds of statements can look like. Flip. Now, folks, whoops, sorry about that. When I am making reference to a standard form categorical syllogism, and I'm going to go for the easy example that in the textbook you would have seen, because it's example number 1 of categorical syllogisms. And if you've learned about syllogisms before in some other context, my apologies, because this is, we're going through it slowly, tiny steps, because I imagine many of us haven't seen it before. Now, this is in the notes, but I'm going to say, a standard form categorical syllogism will always consist of 3 statements. 2 of them are premises, the other one is unsurprisingly the conclusion. The total argument will make references to 3 classes of things, or categories if you prefer. 3 classes or categories must be referred to in those sentences. Now, each category must be mentioned twice, but not in the same statement. Each category must be mentioned twice, but not in the same statement. Now, let's look at a template. The template is the author of the text. First easy example. It's in the notes, but I'm going to write it big here for camera land. All humans are mortal. All Greeks are humans. Therefore, all Greeks are mortal. Fairly standard example. Now, just to give you some nomenclature, every syllogism that is put in standard form will have to be structured in this way. Now, why do we put them in standard form? Well, for ease of communication, mostly. The predicate of the conclusion is what we call the major term. The predicate of the conclusion we refer to as the major term. Any guesses what we call the subject of the conclusion? Thank you. The subject of the conclusion we call the minor term. Now, folks, the major term, if it's in standard form, will be found in the first premise. The premise that we put first, we call the major premise. Here's the major term. It's in the major premise. Guess what we call the other premise? The one we place second is called the minor premise. And unsurprisingly, the minor term must be somewhere in the minor term must be somewhere in the minor premise. Now, folks, there's a term left over that we didn't make reference to. It is the term that is found in both of the premises, but not where? Yeah, it's not in the conclusion, because obviously we're out of terms in the conclusion. Now, the term that's found in the major premise and the minor premise is what we call this the middle term. Call it the middle term because it's the term that somehow is a major force in either properly logically connecting the two terms premises, or failing to do so. So you got the major term found in the major premise, minor term, which is also was found in the minor premise, and the leftover term is called the middle term. Keep those in your data banks. Now, let me throw you some other examples. Now, because of time, I'm not going to be able to demonstrate until our next session why that particular one is valid. But I'll tell you what, it is indeed a valid one. We will be looking at several methods for determining validity over the course of the next two lectures. One of them is called the Venn diagram method. Don't worry, it's a math logic thing, but I will talk you through it slowly. It is easy enough to do as long as you pay close attention and follow the steps. There is also another method for determining validity called the rules method. Now, indeed, understanding the terminology and the structure and memorizing some rules and being able to apply them is all you need to know in order to apply the rules method. But we will go over that too very shortly. What I wanted to show you was one more example before we part this part of the conversation. I want to look at the second example that the author of the text gives us. It's the one that says, all things made out of grass are green. Some things made out of grass are cigarettes. Therefore, some cigarettes are green. All things made out of grass are green. Now, you notice I got rid of the terms, or I should say, I got rid of the content and I substituted letters. The second one says, some things made out of grass, M for made out of grass, are cigarettes. Therefore, some cigarettes are green. Now, ladies and gentlemen, I'll talk this one through in a moment. What I wanted to show you right now is sort of the next step in what you're going to have to be able to do. To designate this, this syllogism, we designate syllogisms in terms of their mood and their figure. I may not have enough time to do figure justice, but I do want to talk about a syllogism's mood. That was in the textbook, but I think quickly glossed over. Now, the mood refers to the letters representing the three statements. The first, this one's already in standard form. The first one is an A statement. The second one is an I statement. And the third one is a what? Also an I statement. So the mood of this syllogism is an A-I-I. What was the mood of the last example we saw? A, A, A. Now, this is where the textbook doesn't do you much justice at all. The concept figure is mentioned. How many of you saw the figure was mentioned? Mentioned one time. But then the concept wasn't very well explained. The figure, ladies and gentlemen, refers to the configuration of the middle term. And I hate to do this to you folks, but you're going to have to memorize this. But guess what? It's really only a couple things you have to memorize. That's the good news. I'm going to ask you to memorize the configurations of the middle term. I'll come back to this. There's four possible ways that the middle term can be configured. And this is kind of set up in the notes. Not these notes, but some other notes that you're going to see shortly. When the middle term is the subject of the major premise and the predicate of the minor premise, we have what's called figure one, or first figure. When the middle term is the predicate of the major premise and the predicate of the minor premise, we have second figure. When the middle term is the subject of the major premise and the subject of the minor premise, we have figure three, or third figure. Finally, whenever the middle term is the predicate of the major premise and the subject of the minor premise, we have fourth figure. Now, a sort of device for helping me to remember this, circa 1989, I'm dating myself a little bit, was doing this. When the first premise is the subject and the second premise, subject, the second one is the premise, or the predicate, that is first figure. When the middle term is the predicate and it's the predicate, it's second figure. When it's the subject and it's the subject, it's third figure. And when it's the predicate of the first one and the subject of the second one, it's fourth figure. Not a mnemonic device, but it is a visual that might help you to remember when you don't have your notes in front of you. When you're doing your homework, you can, of course, have your notes in front of you while you're getting used to this. Now, that last example we saw, folks, that one about the grass, we can talk about that one in a minute. It said all things made out of grass are green. Some things that are cigarettes, or no, I said some things made out of grass are ciggies. Was that it? Yeah. Therefore, some cigarettes are green. Folks, at first glance, this is indeed a good standard form categorical syllogism, and at first glance, it's valid. But it's actually guilty of the fallacy of four terms. Does anyone know why? In the one thing, when they're talking about grass, they're talking about what? The literal stuff that grows on the ground. In the other case, they're talking about weed, reefer, Mary Jane. You know, think of the bear. In other words, when they're talking about grass, they're talking about grass in two different senses. So this syllogism, technically, it's not valid because it's guilty of the fallacy of four terms. Yeah.
So, how are we supposed to? I'm not even relying on the victim of thinking it was really grass.
Yeah. Now let's pretend that that's what it was.
How do you get your mind to turn?
Well, what you have to do is sometimes read into context. Because as far as I know, people do not make any cigarettes out of literal grass. But I've heard that people do sometimes make them out of these other things that are also called grass.
Well, it's kind of hard when you don't smoke cigarettes. I don't smoke cigarettes, so I don't know.
Well, I don't either, however.
I don't know what's there.
However, I've been around the block, and I know the kinds of contexts that people use different words in. Now, let's pretend for a minute that they're using the word grass in the same way. Now, M is used twice, G is used twice, and C is used twice, not in the same premise. It is in standard form because we have the major premise, or is in the major term, and the minor premise is in, or minor term is in the minor premise, and M is our middle term. Now this is in the textbook. The mood of this one is what? A, I. What is the figure? 1, 2, 3. Yeah, this is AII3. Folks, if this one had not made that fallacy of four terms mistake, this one would have been valid. I will tell you via demonstration later on how I know that this structure is valid.
So is it AI item because the subject is M?
Well, the reason why it's AII is because
Well, I know it's AI.
Yeah.
Is it 3 because of that?
yeah, it is 3 because the M is the subject of both terms. So this one is AII3. We will be working more with this shortly, and then we will be looking at methods of determining validity. This is kind of the first little step. Cheers for now.